Because commercial aircraft fly at heights of between 9 and 11 kilometers, an airplane must begin its gradual descent a long distance away from its destination airport. An aircraft is flying at an altitude of 10 kilometers and the angle of descent is 2 degrees, that is, descending at an angle of 2 degrees to the horizontal. At what distance from the destination runway should the descent begin? You can assume that the path of descent is a line. Give your answer in kilometers to the nearest kilometer. So here's the picture. The height of the aircraft when it's here is 10 kilometers. Now 10 kilometers is 10,000 meters. So basically we just want to find this distance, which I'll call x. It's just a side adjacent to 2 degrees in this right angle triangle. So the aeroplane is coming in at an angle of 2 degrees to the horizontal. So it starts its descent when it's 10 kilometers or 10,000 meters above the surface. So we can use our ratios to find x. Well, you could also use the sine rule. I'll probably do it two ways. I'll start off by using ratios for right angle triangles. So we're looking at this angle here, 2 degrees. Well, actually we could look at this angle up here as well, because we can find this angle, but I'll work with this angle here. The side opposite this angle is 10,000 meters. The side adjacent to it is x, what we're looking for. So we need to bring in the side that we're given, 10,000, and the side that we're looking for, x. So we need to bring in the opposite side to 2 degrees and the adjacent side to 2 degrees. Now the ratio that does that is the tan of 2 degrees is opposite, which is 10,000, divided by the adjacent, which is x. Now we need to find x. Well, you can cross multiply and rearrange to get x. You see, we can think of this as tan 2 over 1. 10,000 times 1 equals x tan 2. So x equals 10,000 over tan 2. That's when you rearrange. Or the quickest way to do it actually is just interchange these. So the result of rearranging involves just interchanging these. So you get x equals 10,000 divided by the tan of 2 degrees. Now this angle is in meters. This is 286,362.53 meters. We want this answer in kilometers. Well, there are 1,000 meters in a kilometer. The K stands for 1,000. So what do? We have to divide this by 1,000. So we move the decimal point 3 places to the left. So this is 286.3625 kilometers. We want this value to the nearest kilometer, so we want this number to the nearest integer. So we look to the first decimal place. It's less than 5, so we round this number to 286 kilometers. This number is closer to 286 than it is to 287. An aircraft is flying at an altitude of 9.3 kilometers. A passenger becomes ill and the pilot needs to land at the nearest airport, which is 200 kilometers away. What will the angle of descent be? So here's the picture. The aircraft is at an altitude of 9.3 kilometers and it wants to land at an airport which is 200 kilometers away. So this line here is the trajectory of the airplane. So we're assuming that it's a straight line. Now the angle of descent is this angle here, which I'll call A. So we need to find out what A is. Now, we have a right angle triangle, so we can use the ratio that brings in these two sides. The side that's opposite A is 9.3 kilometers. The side that's adjacent to A is 200 kilometers. So we need a ratio that brings in opposite and adjacent. That's the tan of this angle. The tan of A is the side opposite A, 9.3, divided by the side adjacent to A, which is 200. So we want 9.3 divided by 200. So this is the tan of A. So to get A, we get the inverse tan of this angle, or of this value I should say. The inverse tan is 2.66 degrees. Now to one decimal place, this is 2.7 degrees. Now I just want to go back to question 1. I said that we could do question 1 using the sine rule. I just want to quickly run through it using the sine rule. We got an answer of 286 kilometers. Now when we use the sine rule or the cosine rule, we let the letter A stand for what we're looking for. Now we're looking for a side in this case, so we use small a. So if this is small a, then the angle opposite small a is capital A. Now the angle that's opposite small a is this angle up here. What is this angle? Well, the three angles in a triangle add up to 180. But here we want to subtract off the 90-degree angle, and we want to subtract off 2 degrees. So angle A is 88 degrees. Now we need another side and an opposite angle. So we have to use this side here. It's the only one that we have, so we call this small b. And the angle that's opposite small b is capital B. So the sine rule says that A over sine A equals B over sine B. Now we want small a, so we just multiply both sides of this equation by the sine of A. So we get B times sine A divided by sine B. Now we've done this before, I won't bother writing down what these values, I'll just plug them in. So we have to take B, which is 10,000, and multiply it by the sine of A, which is 88 degrees. Okay, so that's the numerator. And we divide this by the sine of B, that's the sine of 2 degrees. So here we get our answer in meters, and we divide this by 1,000 to get the answer in kilometers. So as before, you see that to the nearest kilometer, this is 286 kilometers.